All right, so are you ready to start our next page? 225. Let's go ahead. So it's a new concept we're going to be talking about called an inequality. So let's go ahead and see what the book says. An inequality is a mathematical sentence in which two expressions are not equal. The greater than and less than symbols can be used to express the inequality. A number line shows all the solutions for the inequality. And the open circle on the number line shows that the circled number is not included in the solution. Okay, let's unpack this a little bit. So example, x is greater than 2. Do you see how there's a circle above 2? And it's showing the arrow all the way to it's drawing an arrow through all the numbers that are greater than 2. So x could be 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, infinity, right? But not 2 because 2 is not greater than 2. That's why the circle is open. So basically, these are potential answers for x. So the number line shows that x is any value that's greater than 2. Example number 2. X is less than 3 minus 1. So first you're going to solve it. So 3 minus 1 is 2, right? So this is basically saying x is less than 2. The number line will show us all the possible answers for x. So if x is less than 2, x cannot be 2, but it can be 1 because 1 is also less than 2. 0 is less than 2. Negative 1 is less than 2. Negative 2 is less than 2, and so on and so forth. So this number line shows that x is any value that's less than 2. Could be confusing, but if we actually practice it, it will help us understand it better. So let's go ahead and try the exercises. Draw a number line to illustrate the inequality. Cool. Number 25. B is greater than negative 2. So all the numbers that are greater than negative 2, we need to show in this number line. How do we do this? Well, first of all, let's go ahead and write down the 0, okay? And fill out this number line. So that becomes 1, 2, negative 1, negative 2, negative 3. Okay, and then go to negative 2, just here. Ask yourself, is negative 2 greater than negative 2? No, of course not. No, because they're equal, right? So we have to open up the circle here because negative 2 is not B. It cannot be one of the answers. All right. How about negative 3? Can negative 3 be B? Is this correct? No, it's not, because negative 2 is actually greater than negative 3. So the arrow will not go that way. How about this way? For example, 0. Is 0 greater than negative 2? Yes. Is negative 1 greater than negative 2? Yes. Is 2 greater than negative 2? Yes. Is 500 greater than negative 2? Yes, it is. That's why the arrow will go that way, not the opposite way. So let's try number 27. C is less than 5 minus 4. So if you have a problem like this, solve it first. So 5 minus 4 is 1. So this is basically saying C is less than 1. So we need to indicate all the possible C's. So let's go ahead and put the 0 down. Write down the numbers here. Okay, and let's go ahead and see which direction this needs to go. Well, first of all, 1. Is 1 less than 1? No. So 1 is not part of the answer, so we're going to put an open circle. Okay, now do we go that way or that way? Well, let's substitute. Let's put 2 in here. Is 2 less than 1? No, 2 is greater than 1. So I think it's going that way, right? Is 0 less than 1? Yes. So it goes that way. Is negative 2 less than 1? Yes. Is negative 5,000 less than 1? Yes. Okay, so that's how you do it. Let's try the next section. Determine whether the given value is a solution to the inequality, right? Yes or no. So this is basically saying, is this true or false? Okay. 29. Y is greater than 3 if y equals 2. So go ahead and substitute this. If y equals 2, is this true? Is 2 greater than 3? No. So you're just going to write no. Okay. 31. B is greater than 10 if b equals 3 squared. Solve that first. 3 squared is 9. So if b is 9, let's go ahead and substitute this. 9 greater than 10. Is this true or false? False. So you're going to write no. Number 33. S is greater than 7 if s is the square root of 9. The square root is the opposite of the exponent. So the square root of 9 is 3 because 3 multiplied by itself is 9. Okay, so s is 3. Now let's go ahead and substitute it. 3 is greater than 7. Is this true, boys and girls? No, it is not true. Okay, so that's how you do that section. Let's go ahead and do our practice and application. I'm going to be doing number 34 and 37 because you need to know the answer for number 34 in order to do 35. So you're going to be doing 35 and 36, and we'll do 34 and 37 together. There will be 23 people at Josiah and Jacob's birthday party. How many packages of hot dogs will need to be purchased if 2 hot dogs are cooked for each person at the party? There are also 10 hot dogs in each package. A lot of information. Let's first find out what is the answer we're trying to find. What are we trying to find? We're trying to find how many packages of hot dogs we need to buy. Packages. Not the number of hot dogs, but we need to find out how many packages. This is a 10-pack hot dog package. Okay, 10 hot dogs in each package. There's 10 hot dogs in this package. How many packages do we need to buy? How many of these do we need to buy? That's what we're trying to find out. But in order to find that out, we first need to find out, well, how many hot dogs do we need to buy in the first place? Let's first figure that out, okay? Because we can't find this answer before that. So, for example, let's see. Not for example, sorry. There are 23 people. How many hot dogs is each person gonna eat? 2 hot dogs are gonna be cooked for each person. Okay, so every single person wants 2 hot dogs. So how many hot dogs do we need to buy? We need 46 hot dogs. Okay, and there are 10 hot dogs in each package. So how many packages should we buy so we have enough? How do we figure that out, boys and girls? What do you think? Well, you're going to be actually doing 46 divided by 10 because there are 10 hot dogs in each package, okay? 46 divided by 10, remember our division shortcut. Just move the decimal to the left one time. So we're going to need 4.6 packages. But if you go to the market and you ask the cashier for, hey, can I have 4.6 packages? Probably can't buy that. So how many should we buy? Should we buy 4 or 5? Well, if we buy 4, it's not enough. So we need to buy 5. We'll have extra hot dogs, but we can give that to our grandma or something, okay? So the answer is 5 packages. The equation you could have done also is 23 times 2 divided by 10. This is how we solved the problem, 5 packages. So for 35, it's going to change a little bit. They're going to say that there's 8 hot dogs in each package, not 10. So how many packages will you need to buy? So you just have to change one of these numbers. I think you know which one. Okay. 37. 400 water balloons were filled. Wow. Jacob figured that each guest that was not an adult would have 26 balloons to throw. So every single guest will have 26 balloons to throw. Then how many extra water balloons were there? Also, there were 8 adults at the party. Again, where do we start? Figure out what we need to find out. We need to find out how many extra water balloons there are after all the kids throw the balloons that they are going to play with. So we're going to try to find out the extra number of water balloons, okay? So what do we need to know first? Well, first we need to know, they tell us how many adults there are, but how many children are there? Because because each guest that's not an adult is going to have balloons, right? So then how many kids are there? Well, if you might have noticed that this practice and application kind of tells a story. So look back at number 34. It says there will be 23 people at the party, right? Jacob, same person. Okay, so then there are 23 people at the party. How do we find out the number of kids if we know the number of adults? We can do 23 people minus 8 adults to figure out how many kids there are. So 23 minus 8, 15 guests that are not kids. that are not adults, sorry. 15 kids, okay? So that's the first piece of info we need. What's next? Now we can see, well, it says Jacob figured that each guest that's not an adult, so basically a child, would have 26 balloons to throw. So each kid is going to be given 26 balloons. So then how many balloons are going to be used? How do we figure that out? Each child is going to have 26 balloons. 15 times 26 balloons, right? Equals 30, 10, all right, they're going to be using 390 balloons, all these children. Okay, then how many are going to be left over? Well, there were 400 originally, and 390 are going to be used. So 400 minus 390 is 10 extra balloons will be left over. Okay, the equation you could have also used, let's put this all in a simple equation, would have been, well, we have the 15 kids, so 400 minus 15 times 26. That was the equation, right? So these are multi-step equations, problems, meaning that you need to kind of do a lot of different operations in order to come to the conclusion. They're kind of like puzzles, right? So yes, that is it for the class. You can skip J if you would like to try it. Of course, you should try it. And yeah, that is it. Go ahead and do the even numbers. And if you have any questions, contact me. Really, really good job, you guys. You guys are becoming professionals at solving equations, and I'm very proud of you. See you soon.